All right, hello, welcome to Algebra 1. Today's lesson is inequalities involving absolute value. Let's get started. Previous objective, if you recall from Chapter 2, we solved equations involving absolute value. And today we're going to solve and graph absolute values that include inequalities that are less than and greater than. Again, make sure you get the objective written in your notes. There's no vocabulary for this lesson, but there are some key concepts that I want you to write down that are going to be further explained throughout the lesson. The first one is that the less than symbol represents our ands or our intersection. Our greater than symbol is our ors or our unions going in the opposite direction. If the equation is less than a negative, it is no solution. And if the equation is greater than a negative, it's all real numbers. Again, I want you to write these key concepts down and they will be further explained in the lesson. We are going to start right off the bat with our multiple choice question on the Google page. So which graph is the solution set of the compound inequality b is greater than 3 or b is less than 0? A, B, C, or D? Make sure you record your answer in the Google form at the end of the video. Let's get started with example number 1. It says solve the absolute value of s minus 3 is less than or equal to 12 and then graph the solution set. Just as I had you write down in your key concepts, whenever we see the less than symbol, if it's set equal to a less than, it is a and it's an intersection. So we know that this graph right off the bat is going to connect in the middle. So we are going to write, if you recall back from chapter 2, we set absolute value equations two different ways. We had the first case scenario, which was solved just the way it was written. So s minus 3 is less than 12. And then the second case, s minus 3, we have to flip the sign and then flip the 12 to negative 12. And if, again, from chapter 2, we wrote it just the way it was written, and then we set it equal to a negative. Well, because we're dealing with inequalities, now it's an added step. You also have to flip the sign when you solve it the second time. All right, so I'm going to add 3 to both sides. And I get s is less than or equal to 15. And I'm going to add 3 to both sides. And I get s is greater than or equal to negative 9. All right, because I know they meet in the middle, I'm going to start with my negative on the left side. So negative 9, I know s in the middle. S is greater than or equal to negative 9, but less than or equal to 15. And that is how you would correctly write this and solve this inequality involving absolute value. When we graph it, we have negative 9. It's a full closed circle because it includes the it equals negative 9. And a closed circle at 15. And again, they meet in the middle. All right, let's do the absolute value of x plus 6 is less than negative 8. Well, because whatever this value of x is cannot be negative, it has to be greater than 0. So it would never be less than a negative 8. And again, this is one of those key concepts that I had you write down at the beginning of the video, is that if the equation is less than a negative, it's an empty set. So keep that in mind, because it has to be greater than 0, it would never be less than a negative 8. Empty set, no solution. All right, we are at our first checkpoint. So if you want to pause the video, I want you to solve this absolute value inequality and then graph it on a number line. We'll come back together and see if we got the same answer. All right, I'm going to get started. I get p plus 4 is less than 6. And then I'm going to solve p plus 4. I'm going to flip my sign and make my answer a negative to find my two solutions. So I'm going to subtract 4 from both sides. I get p is less than 2. And when I subtract 4 from both sides, I get p is greater than negative 10. So I'm going to put p in the middle. I'm going to start with my negatives on this side, just like you would a number line. P is greater than negative 10, but less than 2. So if I have to graph this on my number line, down at -10, it's an open circle, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2. It's also an open circle at 2. So it's everything greater than -10, but less than 2. Hopefully you got the same answer as I did. All right, another checkpoint. If you want to pause the video and see what you get, and we'll come back together and see if we get the same answer. All right, just like I mentioned, if your absolute value inequality is set less than a negative, your answer is no solution. So hopefully you looked at that right away and you knew that the answer was no solution. All right, now we're going to move on to the next example, which is solving absolute value inequalities that are set greater than. Now what I wanted to point out is that these are our unions that involve the word or, meaning that they're either going to go in the opposite direction or the exact same direction. So I have 3y minus 3 is greater than 9, and I have 3y minus 3. I'm going to flip my sign and flip my answer, or what it's equal to. So now I'm going to solve it. Add 3 to both sides. I get 3y is greater than 12, so y is greater than 4. And then I'm going to solve this side. I get 3y is less than -6, so y is less than -2. All right, so when I have to graph this on a number line, I know it's a union, meaning that they're not going to connect in the middle. So I have -2 down here, my big or in the middle. It is less than, an open circle, less than -2. -1, 0, 1, 2, 3, 4, but greater than 4. So again, our inequalities that are greater than our ors are unions, and they're going to go in the opposite direction or the exact same direction. And as you can see, the graph I had there is the exact same as what I created up right above it. All right, let's move on. In your key concepts at the beginning of the lesson, I shared with you that if it is set equal greater than or equal to a -11, that it would be all real numbers. And that makes sense because we know that absolute value has to be 0 or higher. And 0 or higher is always going to be greater than or equal to any sort of negative number. So our answer is all real numbers. All right, example 3, we are at a checkpoint. This is a OR problem, a union. So if you want to pause the video and come back together and see what you get for this inequality. I am going to start by x plus 5 is greater than 2, and then x plus 5 is less than a -2. So I'm going to subtract 5 from both sides, and I get x is greater than -3. And I subtract 5 from both sides, and I get x is less than -7. All right, so here are my two solutions. On my number line, I have -7 down here. It's an open circle. It's everything less than -7, -6, -5, -4, -3, -2, -1, 0. It's an open circle at -3, and it's going in the opposite direction. It's everything greater than -3. All right, hopefully you got the same answer. Now we are to the open-ended question on the Google page, and I understand that it's going to be, again, difficult to graph this. So what I want you to do is just write in your answers, and then we'll take a look at your graphs together in class tomorrow. All right, that's it for 5.5. I will see you again for the next lesson.